Alrighty, let's go over the warm-up. This is lesson 5.5. Okay. In number 1, they want us to list the angles in order from smallest to largest. All right, team, who can give me the smallest angle in this triangle? Ooh, Matthew, what do you think?
Angle Y.
Angle Y. You're correct. Why? No.
What's the line across? The side across.
Yep. The side across from angle Y. What about that side?
Is similar to the angle.
Okay, but this side in comparison to all these sides is what?
Shorter.
Good. The shortest side is across from the smallest angle. The smallest side has to be across from the smallest angle. Good. Yep. Perfect. What's my next smallest angle?
W.
Yes. Why?
It's across from 6.
It's across from 6, and that's my next shortest side. Good. Meaning angle X, which is across from my largest side, should be the largest angle. Okay, that's what we talked about in 5.3. By the way, we do skip 5.4. We go to 5.5. I think it's like a proof section or something. All right, and number 2, this time they want me to list the sides in order of smallest to largest. Who can tell me what my smallest side would be in number 2? Malin.
KL.
KL, correct. Why?
Because it is across from 32.
Exactly. It's across from the smallest angle, which is 32 degrees. Nice. Perfect. Couldn't have said it better myself. What is my next smallest side?
JK.
JK. That's across from my next smallest angle. Good. And then my largest side across from my largest angle, in this case, my this obtuse angle, would be JL. Okay. So these are accidentally ordered 1, 2, 2. So just change that to a 3. This one was interesting, this last one. I like it because they're a little bit of algebra. It says order the sides of triangle DEF in order from least to greatest if the measure of angle D is x plus 6 degrees, measure of angle E is 5 times x minus 8, and the measure of angle F is 9 times x plus 2. Okay, so you could sketch a little picture if you wanted to help you. We have some triangle DEF. Not that it really matters. DEF. Okay. And they do give me all the angle measures, but since they form a triangle, what should all of those angle measures total up to be?
180.
180, right, because they form a triangle, right? Wow, you guys said that like in perfect unison. Was somebody like counting off?
Yeah.
So to solve for x, the equation you could have set up to figure out what x is add all these angle measures together. And we know since they form a triangle, this has to add up to 180. So when you solve this, you got this far. You should have gotten x to be 12. Meaning angle D, I'm just going to label it right here in my picture. Angle D is 12 plus 6. That would be 18 degrees. Angle E, 5 times 12 minus 8 is 52 degrees. And angle F, which is 9 times 12 plus 2 degrees, was 110. Okay, my picture is not quite drawn to scale, but that's all right. They didn't ask me to order the angles. They asked me to order the sides. So drawing this picture kind of helps you see which side would be the smallest here. Well, the one across my smallest angle, EF. And then my next smallest angle would be across from side DF. And then my largest angle should be across from my largest side, DE. Now, obviously, if you have those flipped around, meaning like FE instead of EF, that's fine, but they need to be in that order. Okay, that was a review from 5.3. Good stuff. 5.5 is a pretty short lesson again. And it's basically focused on one big theorem. So before I introduce you to that theorem, I want to hear from you guys. Your thoughts on this. So triangles are made up of three sides, right? Yes, Ms. Henchers, they are. Okay, great. If I gave you any three lengths of like sticks, if I give you 3 sticks, could you always form a triangle perfectly, making all like the vertices meet with any 3 lengths?
Yeah.
You think so?
Yeah.
Okay, let's look at decimals. Okay, so here's your 3 sticks. What if I gave you, so these 3, well, we could still form like a triangle. It wouldn't be a perfect triangle, right? I'd have a little bit left over of my sticks. But what if I gave you like a really, really, really short stick, like this one was only like 5? Could you form a triangle with these 3 lengths?
Yeah. Well, maybe not.
No.
Try hard enough. Divide by 0.
Not possible.
Exactly.
Okay, so the answer is actually no. It kind of depends, obviously, the lengths of your 3 sticks to determine if they would form a triangle. And that's what this theorem allows us to figure out, okay? So the answer to this is actually no. Here's a theorem. It's called the triangle inequality theorem. And it says the sum of the lengths of any 2 sides of a triangle have to be greater than the length of the 3rd side. Okay, so looking at my picture here, I have these 3 sides. I got PQ, I'm going to use red for that. I got QR, I'm going to use blue for that. And I have PR, which I'm going to use green. So what this theorem says is that as long as you add any 2 sides, I'm going to start with PQ and QR. And as long as their sum means add, is greater, here's where the inequality comes into play, is greater than the 3rd side, which in this case would be PR, then it's going to form a triangle. But you have to show it for all like 3 sides. Okay? So this one's just adding up the red and the blue side. I would also have to add up like the blue and the green. I would have to show that QR plus PR. I'd have to show that distance, that sum, is greater than the 3rd side, which in this case would be PQ. And then lastly, my other combination here would be if I had PQ plus PR, that sum of those lengths is greater than the length of the other side, which is QR. As long as all of those are true, then it can form a triangle. That's what this theorem allows us to show. Okay, so let's go back to that example I gave you here. So AB, also, I know this is maybe it would look kind of confusing here, but all this is saying is like here's the length of AC, the length of AB. So I like move this slider. Started off something right here. I move the slider to make this one just a length of 5. So let's say this is red. AB is 9. Let's say this is my green one. BC is 5. So the reason why, according to this theorem, this doesn't form a triangle is because that sum, what's the sum of 9 and 5, folks?
14.
Is 14 greater than 15? No. So the sum of those 2 sides is not greater than the distance of the 3rd side, so I would automatically know we would not be able to form a triangle. That's what this theorem says. Okay, one other thing I want you to add in your notes under this theorem is to show that it's not possible to form a triangle. Not possible to form a triangle with 3 given lengths. All you have to show is that one of these inequalities isn't true. So in that example I just did on decimals, I picked the shorter 2 sides, and I showed right away that inequality wasn't true. So you don't even need to check the other sides. You just need to show one inequality. One triangle inequality is not true. So I'll model this every time we do these problems, but I always start with the smallest two sides and add them together because obviously if there's going to be a sum that might not be greater than the distance of the third side, it's going to be the one of the two shorter sides. So that's kind of how I start. And if I can show this right away, like by adding the two smaller sides, the distance is not greater than the third side, automatically the answer is no, it's not going to form a triangle. Okay, make sense? That's basically all our theorem is today. Just going to do a couple example problems in here. Okay. Let's try this one. Is it possible to form a triangle with side lengths of 6.5, 6.5, and 14.5? Okay, probably already know the answer, but let's go through what you need to show for work. This you don't need to show, but always check. It's just like my little advice to you. Check the sum of the two smallest sides first. You can save yourself a lot of time. So in this problem, my two smallest sides would be 6.5 and 6.5. Here's what you need to show for work, what I'm writing down right now. You need to show that you're testing if this distance, is this greater than, put a little question mark above that. We're testing, is this greater than the length of my third side, which is 14.5? Well, folks, what's 6.5 plus 6.5? 13. Is 13 greater than 4.5? No. So you can stop there. No. Won't form a triangle. Okay, so that's what I was saying on that last slide. You only need to show that one inequality isn't true, and that automatically means it can't form a triangle. Won't, can't, whatever you want to say. Okay, let's try another one. So fun. What do you think if I have side lengths of 6.8, 7.2, and 5.1? All right, so as I mentioned, I like to start with my two smaller sides first. So in this case, it'd be 5.1 and 6.8. So is that sum greater than the length of the other side, which the other side I didn't use was 7.2? What do you guys say?
Yeah.
Yes, this is 11.9, and that indeed is greater than 7.2. Good, check. Yep. You do have to show all three sides, according to this theorem. You have to show all three sides. So, doesn't really matter where you go from here. I'm going to do 6.8, and I'm going to add it with 7.2. So that has to be greater than what, folks? 5.1, my other side. Obviously, it's going to be when both of these sides are bigger than 5.1, but we got to show this to prove, or to use this theorem. We got to show the hypothesis here that this is met. Okay, and then my other combination I haven't done, my 5.1, my smallest side plus my largest side yet, plus 7.2. You should put question marks above these two. That's kind of picky, but technically we're like testing. Is that greater than 6.8? You betcha. Check. So yes, would form a triangle by the triangle inequality theorem. In case you were asked to state why. It does say explain why or why not by the triangle inequality theorem. Okay. 2 down, 4 to go. Why? All right, another possible type of problem you might be asked is, what is the possible range of values for the length of this missing side in order for it to form a triangle? So in this example, it says we have a triangle PQR. PQ is 7.2. QR is 5.2. What possible lengths could PR be? I'm going to call that X. Okay. So I'm going to set up my 3 triangle inequality theorems. Well, inequality kind of like statements, I guess. I know that, let's start with my smallest side like I usually do. 5.2 plus my missing side, X. I know that has to be greater than the other side, which in this case would be 7.2. That's one criteria. Doesn't matter what order you set these up in. You have to set up all 3. I also know that my side 7.2 plus that missing side of X, that has to be greater than what, folks? 5.2, exactly. Okay, which combination am I missing? What else do I need to set up? Okay, good, Lillian. Keep going. 5.2 plus 7.2 has to be greater than what? Good. 5.2, my 2 known sides, their sum has to be greater than my missing side. Has to be greater than X as well. Good job. Okay, so I have 3 inequalities that I just need to do a little algebra to solve here. Solving inequalities are exactly like solving equations, except there's one tiny difference. Does anyone know what I'm thinking of? What's the one difference when I'm solving inequalities or solving equations? Guess?
Is it because, like, I don't know, I'm just guessing, like, when you add them, it might not, like, because there's equations, when you, like, add the 2 things, X equals that, but
Okay.
it might not, like, X might not equal their sum.
Okay, you're right. It gives us more of like a range of values. That is one difference. So like here, to solve this for X, you would, treat this as like a normal equal sign. You'd move over this 5.2. So I think what Lillian's saying here is like, this says that X isn't 2, but that X has to be greater than 2. Now, if it was greater than or equal to, it could be 2. But in this case, this gives us a lot of values. This says your missing side has to be greater than 2. So it could be 2.1, could be 10, could be 14, could be 100. Lots of possible answers here. Algebraically, though, what's one small difference when I'm solving inequalities versus solving equations? Do you know what I'm thinking of? Another guess?
I don't know, that it's not an equal sign.
Okay, yeah, you're right. But there's like one small like algebraic, it's just something you have to remember to do when you're solving inequalities.
Oh,
Yes.
flip the sign.
When what?
When it's when it's positive or negative or something like that.
Okay, add on.
It's either when you're dividing or multiplying
By
by a positive number,
close.
negative number.
Negative number. Anytime you multiply or divide by a negative number, you have to flip the symbol. Remember that?
Yep.
Oh, good times. Okay, so just keep that in mind. There's only like one example problem that it could like possibly come up, but here I was just subtracting, so I didn't have to worry about it. But just in general, remember when you're solving inequalities, if you ever multiply or divide by a negative, yeah, flip the sign. Okay, let's keep going here. To solve this one, I would have to subtract 7.2 from both sides, and I get X has to be greater than negative 2. So my first statement said X has to be bigger than 2, and this one says that X has to be bigger than negative 2. This kind of overlaps a bit, right? If X has to be greater than negative 2, but also greater than 2, in order to fit both criteria, we'd have to say, well, it still has to be bigger than 2. Okay, so just kind of some thinking as we're going here. All right, this one over here, when I add these together, I get 12.4 is greater than X. Now, anytime I had my like Algebra 1 students solve these, I told them, rewrite this with your variable on the left. It's way easier to read this. This also says, if you were to read it this way, this also says X is less than 12.4, right? Right? It's still eating the bigger number. I didn't flip the sign. I'm just rewriting what that says. So here's what I come up with. x has to be greater than 2, greater than negative 2, and also less than 12.4. So that kind of cuts off some possible values. One I mentioned before was 14. Well, now according to this, it can't be anything bigger than 12.4. So we can essentially ignore this, because if x has to be greater than 2, it's going to be greater than negative 2. So I'm going to write these in a compound inequality of a way of basically saying any values in between 2 and 12.4. Okay, now how I write that with interval notation here is I put my small, this will be familiar, you do this in algebra. You put your smallest number first, and then your largest number in here, and you put your variable in the inside, but we're going to actually call this PR. And then you do less than symbols, and that says every value in between 2 and 12.4. Okay, now, the reason why this makes sense, first of all, I can see this piece right here, PR has to be less than 12.4, that's what this piece says. And then reading it this way, that PR has to be greater than 2, that's what this piece says. So I always call these ones like a sandwich. I bet if I drew this on the board, you do these a lot in algebra where you have to like do a number line. And here you do open circles, and you want to shade everything inside. These are called compound inequalities, kind of ringing some bells. Yeah. Okay, so that's what that would say. That's my range of values. PR could be anything in between 2 and 12.4, and it would form a triangle. Those are all my possible distances of that third side. Okay, make sense? Okay, let's do another one. This time my triangle has a side length of 14 and another side length of 9. Stick with my colors here on the screen. Describe the possible lengths of the third side. Let's call that x again. Okay, so just like before, let's set up my 3 triangle inequality statements. That 9 plus the missing side, that has to be greater than the other side of 14. There's one criteria. Second criteria, 14 plus my missing side length. Again, doesn't matter what order you put these in. That has to be greater than 9. And then lastly, my 2 given side lengths, 9 and 14, their sum has to be greater than my unknown side of x. Okay. Let's solve these quick. So here I just minus 9. I get that side has to be greater than 5. Okay, noted. Here, I get x has to be greater than negative 5. Well, if it already has to be greater than 5, it's going to be greater than negative 5, so you kind of ignore that. This would take care of this criteria. Over here, 9 plus 14, we get 23. Is greater than x. Another way to write this would say that x has to be less than 23. So to write this possible range of value, I want to compound inequality this. I want to sandwich it. Start with 5, start with 23. It just says find the third side, so we can call it x, that's fine. And then put your symbols that way. And that says everything in between 5 and 23. So could I have a side length of 5? No. No. Because then here, if it was 5, I would get 14 is greater than 14. That's not true. 14 is not greater than 14. Okay. Oh yeah, we got a good algebra one next. Give it to me. What are the possible values of x in this triangle? Okay, let's color coordinate my side here. I have an x plus 5, 2x plus 1, and a 4x minus 3. Using the triangle inequality theorem, who can set up like one inequality for me? Tyson?
X plus 5 plus 4x minus 3 is greater than 2x plus 5.
Perfect. He said x plus 5 plus 4x minus 3 has to be greater than that third side of 2x plus 1. Thank you, Tyson. Okay, somebody give me another one. We'll solve that in a minute. Let's set them all up first. Looking for somebody new. Alex?
2x plus 1 plus 4x minus 3 is
2x plus 1 plus 4x minus 3 is greater than x plus 5. Beautiful, thank you. All right, what are we missing? Somebody that hasn't answered a question yet. I feel like Matthew answered one, Tyson, Malin did, Lillian did, Allison, come on. Hey, can I do it? You sure? Ben!
Alright, x plus 5 plus 2x plus 1 is greater than 4x minus 3.
Beautiful. All right. Thank you guys for setting those up for me. So that takes care of all three of my criteria. Now we get to solve these. So if you are one of those people that knows you're going to forget that if you multiply or divide by a negative, you're not going to flip the symbol, my advice to you is anytime you're solving these, move the variables to the side where there's more variables. All right, so if I'm looking at this first one, first of all, I got to combine these like terms. I have 5x, 5 and negative 3 is 2. In this case, where are there more variables, on the left or on the right? On the left, right? There are 5 x's here, 2 here. Move them all to the side where there's more, and then all your variables will stay positive. You don't have to worry about flipping any signs or any of that nonsense. Okay, so from here, once you get all your variables together, you're just taking off the layers around x. Oh! Do I gotta flip my symbol here? No, the number I'm dividing by is positive. Just because this number is negative doesn't mean I flip it. All right, my first statement says x has to be greater than negative 1/3. Okay, cool. Next one. 6x minus 2. Again, there's more variables on the left. So I'm going to move the x's over here. Never hurts to review algebra skills. Never hurts. Take off the layers around x. I get x has to be greater than 7/5. Okay, so what I have so far is that x has to be greater than negative 1/3, but x also has to be greater than negative 7/5. So you can kind of ignore this because as long as it has to be greater than greater than 7/5, it's gonna be greater than negative 1/3. Okay, you should have like an overlapping one like that. Okay, last one. 3x plus 6. This time I have more x's on the right-hand side. That's okay. Think of it like a party. You want to go where there's more variables. It sounds like a more fun party where there's more people. And then here, it's going to add 3. So I get this statement that says 9 is greater than x. That's one way you could say it. Or you could say, and I encourage you to do this, x is less than 9. So of my two numbers, the smaller one is 7/5. The larger one is 9. So x has to be somewhere in between 9 and 7/5. And again, that matches up with my findings here. This says x has to be greater than 7/5. This says x has to be less than 9. You just share the x. Sandwich it. Okay. Any questions so far? Not bad, right? Pretty easy lesson. Okay, I only have one more word problem to do, and then that's it. The towns of Jefferson, Kingston, and Newbury are shown in the map below. Prove, don't worry, we're not going to do a whole full-blown proof. Prove that driving first from Jefferson to Kingston, and then from Kingston to Newbury, is a greater distance than just driving from Jefferson to Newbury. Okay, so I'm going to do here to here in red, here to here in blue. I need to show that that distance is greater than this distance. So, let me ask you this. Is JK plus KN, is that distance going to be greater than JN if they form a triangle? Yes! So you see, by the triangle inequality theorem. And that's a wrap on lesson 5.5.